one with the holes in it to test.
Yes, okay.
With the same
So what are they kind of getting at there?
They think the larger the ball, the farther it's going to go.
Yeah, so...
I don't know if that's a good concept or not. I don't know if that's going to hold up.
Well, let's remind ourselves what we found. What did we find was the case?
That the large... No.
You said it was the bigger the mass, the less acceleration that is?
Well,
Okay.
we talked about the density.
Yeah.
The density and the wind resistance.
This has so that the activity I had you all do is really so let's talk about this because it could be very confusing.
Yeah.
What I've told you is that the larger the mass, the lower the acceleration.
Right.
Okay. In the styrofoam ball example, there's another force happening though. There's another force involved. It's very crucial to that activity, which is, well, what do you, okay, friction.
Air resistance.
So air resistance. So why is air resistance pretty important in that particular activity?
Because the surface of the balls are rough.
Well, the mass isn't
And the
enough,
mass
though.
wasn't, yeah.
The mass wasn't enough.
They weren't dense enough and heavy enough.
Let me ask you this question. If we took, let's remember that small ball that you guys threw? It's been a while, so let's remind everybody. What if you took a really tiny styrofoam ball and you tried to throw it far, what happened? Okay, now if you took a ball the very same size that was, let's say a golf ball. A golf ball was a little bigger than that ball. A ball that was kind of the kind of consistency of, and you threw it, would it go farther or shorter? Why?
Because the mass is greater, the same amount of force.
Well,
has a greater mass because of its density, but a greater mass nonetheless.
okay, so this is where I have to be careful because I'm afraid that I may be confusing you all. If given the same amount of force on two objects, if one is more massive than the other, it will accelerate less, right? Okay. So it's kind of the opposite of what you're imagining. But let's remember that the force, okay, Linda got me in trouble here.
Yeah, there's a lot.
There's too much going on.
Okay,
Well, because
let's
the
walk
ball,
through it. Let's
golf
walk through
balls
it.
intended to fly, like
Baby steps.
the
When I let go of the ball,
heavier,
when I let go of the ball, right?
smoother.
Is there what's the force on that object?
The push force of your hand.
No, once I let
Oh,
go.
once you let go.
What's slowing the one down? Why is the one slowing down? Yeah, the air resistance.
Yeah.
Let me step back even. Let me step back one more. Right as we let go, would you agree that both balls are going the same velocity? Right as we let go.
Yes.
Okay. Now, forget about the hand. We have two balls moving through the air.
So the smooth and so the wind is not.
So this is this is heavy, and this is light, and they just left my hand at the same velocity.
Well, no, wait a minute.
Inertia.
Are you
well,
saying the
it's
same
not force,
velocity or the same force?
As right as they leave my hand.
If they're at the same velocity.
If they're the same velocity, it's one thing.
But if we give the same force, then one's going to accelerate less and have less velocity.
Okay.
But we're supposed to have applied the exact same amount of force.
Which means it's going to have less velocity when it
That's
leaves the hand.
basic force.
Okay. So
I think that's the basic.
It's not about velocity.
When they leave his hand, though, they're going the same velocity. You're accelerating in this part, but
But there's no force.
you're exerting more force on one than the other.
So,
If
right,
you're
that's what I'm
assigning, if
saying.
you're the same force on both, they're not going the same velocity.
Same force, but what I was
They have the
understanding
same
was you were
departure
releasing
point.
them the same.
Well,
It's not the same
well-
velocity.
I teach first grade.
But if it weighs, if it has
What did she say?
I think first grade. I think they're bringing a very
We're actually saying the same thing in different ways, I think, actually. It has to do with if they're released at the same velocity, they're going to be the same. If they have the different force in, you're right. They're going to go different way, or if they have the same force, they're going to go differently.
Here's the thing. You're accelerating. You're only accelerating that object while it's in your hand. Once it leaves your hand, it's no longer accelerating. But you're right. If you accelerate it for the same amount of time, I mean, if you applied a force to both those objects for the same amount of time, one would be, the light ball would be moving faster than the heavy ball, right?
if it was the
That's
same
what you're
force.
saying, and that's correct.
But it slows down faster as
Okay,
well.
but let's, so let's, for the sake of argument, let's assume they both leave your hand at the same velocity.
Okay.
Okay? Now, what's going to happen?
One will decelerate faster rate.
There's a heavy one and a light one, right? What's the force on these objects now?
Gravity.
Okay, there's gravity down, and then is there any force along this direction?
Wind resistance.
Air resistance.
It's the other way.
There's air resistance this way. Now, is the air resistance any different between the light ball and the heavy ball? This is kind of a hard...
Are we
Light and
assuming that they
heavy?
have the same surface?
Or surface. That's the difference.
Yeah, the same surface. Let's say it's precisely the same surface,
The resistance
same
is the same.
shape,
Then it should be
But
the
not the
same.
same surface
Should
area.
be.
same surface area.
The answer must be no.
No, it's not. No.
It's the same.
No. The answer is
So
that.
doesn't, there is a difference.
Well, yeah, it does. The same air resistance is on both objects.
The difference is the force of gravity is going to pull one down, which is going to change the resistance of the air, maybe? I don't know.
Resistance of the air.
If these have the same force on them,
I don't know.
but this one's much heavier.
It's
One's
less.
going to fall straight
Weight
down
is
rather
less.
than
The
down.
more weight is less.
Well, let's not even, don't even worry about the equation. I'm sorry.
Oh, right.
If,
No.
if
Yeah.
this
it's
thing
what's
is heavier,
affected.
if it's got more
Yeah.
inertia,
Yeah. Yeah, that's what you said. That makes sense.
and there's a force opposing it, how do you expect the heavy one and the light one to behave in the situation? You've got a heavy ball and a light ball. They have the same force pushing back on them.
The heavy one is less effective.
The heavy one's less effective.
So it's going to
It's
continue
going to
going.
it's going to decelerate less than the light ball.
Mm-hmm. Just like a paper airplane versus real airplane, in a sense.
So once it's in the air, that air resistance, although the balls have the same amount of air resistance against them, because the heavy ball has more inertia, it doesn't slow down as quickly.
And has more inertia because it has more mass.
Yes, mass and inertia, you want to think of them as
Yeah.
essentially being the same. They're the same thing.
Now the question becomes, if you apply the same force to them, which means that the heavier one's going to be going slower, would they end up in the same place?
No.
Or there's way too much more going on there than we could describe?
Yeah, so that does complicate things, right? Because what that says, what you're saying
But then
there
you're going to have to check the difference.
is this light one starts off going faster, but might
But
accelerate
it slows
really
quicker.
quickly.
If you take a
Well,
lighter
this-
object and a heavier
If you
object,
push them
and you
forward?
drop them at the same height, they hit the ground at the same time. So
Absolutely.
why would that be different?
'Cause the
Because of
inertia.
force behind it?
Because of
Well,
the inertia.
here's the thing. It wouldn't actually, so
It's very
this is
slow.
kind of what this
I don't think
exercise
it is.
shows you, is that the classic Galileo example isn't always true, right? Because of wind resistance.
Yeah.
All right? If you drop a little tiny styrofoam ball and a bowling ball from the top of the Empire State Building, they're not going to hit the ground the same. Okay? And that's because the air resistance is not, for a very light thing, can overcome the inertia. And that's what's happening. The air resistance, because these objects are so light, that small styrofoam ball, its density is so low, that the air resistance overcomes its inertia very quickly. Okay.